Other types of equations and applications, continuing on another time. I promise it's the last time. So we're going to cover two other types of equations that we might run into. The first type is an equation with rational exponents. Okay, so let's give an idea of what we're talking about here. What if we have the square root of x cubed is equal to 8. Now obviously this is a very simplified one. This can be rewritten as, remember the index is 2, can be written as x to the 3/2 is equal to 8. Now a simple process for eliminating this rational exponent is just to raise this to the reciprocal power. Remember, if you have a to the m raised to the n, then that's equal to a to the m times n. Well, if m and n are reciprocals, so if m is equal to 1 over n, they're reciprocals, you can even put that over 1 if it makes you feel better, then when you multiply them together, you're going to get 1, and that eliminates your exponent. So it's a pretty simple method that we can get rid of exponents like this. So in this particular case, that would be saying x to the 3/2 raised to the 2/3 is equal to 8 to the 2/3. So that cancels this out, so x is equal to 8 to the 2/3. Now, that's just 8 squared, the cube root of, so we could write it as x is equal to the cubed root of 8 squared. The cubed root of 8 is 2, so x equal to 2 squared, or x equal to 4. And then we just plug it in to make sure it works. So the square root of 4 is 2, 2 cubed is 8, and it did work. So that's a way that we can do this, just raise it to the reciprocal of the power, and it wipes out that power. So let's do a couple examples with this, just to make sure we're sure what's happening. So if I have x to the 3/2 is equal to 216, I'm just going to look at that power and raise it to the reciprocal. So x to the 3/2 raised to the 2/3 is equal to 216 raised to the 2/3. Now in reality, this isn't really different than what we did when we were dealing with radicals. It's just now we're also dealing with a power involved with it too. So we're using the numerator and the denominator of this exponent. So that's going to give us x is equal to the cubed root of 216 squared. The cubed root of 216, no idea what that is. 6 times 6 is 36. 36 times 6, believe it or not, gives us 216. So x is equal to 6 squared, or 36. So then of course we want to plug that in here and make sure that actually works. So the square root of 36 is 6. 6 raised to the 3rd power is 216, so life is good. Let's try another example. X plus 7 to the 2/5 is equal to 4. Now why are we doing this? Well, this is going to give us another couple steps we need to do along the way. So obviously this is raised to the 2/5, so we're going to raise it to the 5/2, the reciprocal. So x plus 7 to the 2/5 raised to the 5/2 is equal to 4 to the 5/2. That's going to give us x plus 7 is equal to, well, I see half over here, that means square root. I know the square root of 4 is 2, so that's good. So I'm just going to make that 2 to the 5th. I need to subtract 7 from both sides. X is equal to 2 to the 5th. Well, 2 to the 5th is what? 2 times 2 is 4, 8, 16, 32. So 32 minus 7. So x is equal to 25. So now we want to make sure that that works. 25 plus 7 is 32. 32 squared. I'm going to grab the calculator again, just so I don't make foolish mistakes in my head. So 32 squared is 1024, and then the 5th root of that, not using my calculator, so it just takes me a little moment to get to that. So we want the 5th root of 1024 gives us 4. So we're good. That one worked. So that's one thing, is when we're dealing with rational exponents. So let's get this out of the way and look at the other type of equation we want to look at. And the equation we now want to look at are equations in quadratic form. And what I mean by that is they have the properties of a quadratic, but maybe there's something else in there instead of just a single variable. So basically we're talking about substitution. Substitute in a variable that makes it so that it's a quadratic, solve that, then substitute back in. And we've dealt with this before, so it's not that much of a change. But let's say we have x minus 3 to the 1/2 minus 6 times x minus 3 to the 1/4 plus 8 is equal to 0. Now, one of the key things that's going to tip us off that we need to do substitution is the fact that we're going to see some repeated monomial or polynomial, in this case x minus 3, we see in both of these. So that means substitution, but we want to make this so that it's squared to the 1 to the 0. See, there's no x minus 3 there, so that's fine. So how do we do that? Well, first of all, I want to point out that 1/2 is the same as 2/4. I just do that because we may notice pretty quickly then that if we can pull out that 4th, we're left with 2 and 1. So I'm going to let u equal x minus 3 to the 1/4. By doing that, this will turn into an exponent of 2, and this will turn into an exponent of 1. So we have u squared minus 6u plus 8 is equal to 0. Well, that's pretty easy to work with. Two numbers that multiply to 8 and add to -6. Signs are going to be same. They're both going to be negative. -2 and -4. So we have u minus 2, u minus 4 equal to 0. Now I can go back and substitute this back in. And so I can say x minus 3 to the 1/4 minus 2 is equal to 0, and x minus 3 to the 1/4 minus 4 is equal to 0. Well, if we want to do that, let's move it over to get this by itself so we can then take the reciprocal power. So I'm going to say x minus 3 to the 1/4 raised to the 4. Right, so we're going to raise that up. I'm going to move the 2 over to the other side, so is equal to 2 to the 4. So that works out nicely. So that's x minus 3 is equal to 2 to the 4 is what? 16. 2 times 2 is 4, 8, 16. So x is equal to 16 plus 3 or 19. Well, with this one we can do the same thing. X minus 3 raised to the 1/4 raised to the 4 is equal to 4 to the 4. So we get x minus 3 is equal to 4 to the 4, that's 16 times 16, 256. 256. So x is equal to 259. And of course at that point we would go in and we would verify those two values and make sure they work in that. And I'm going to say, I'll leave that to you because it's good experience for you. So we go through that and then we can plug it back in and verify. Also, it's just a matter of plugging in calculations and just takes up more space on the board, whereas you can go and plug that in and see if it works. Well, let's try another example of this where we have to use the substitution. (15x to the negative 2 minus 4x to the negative 1 is equal to 3. Now, if we look at that, I see negative 2, negative 1. So my thought is that we can let u equal x to the negative 1. I'm basically looking at that's going to tell you, because we want this to be equal to 1. Well, if we make this x equal to negative 1, then we're left with just the variable itself, the new u. So we have 15u minus 4, u squared, minus 4u. And I'm going to bring the 3 over, so minus 3 is equal to 0. At this point, we can either use the quadratic formula, or we can see if we can do it by grouping. I'm going to be lazy, and I'm not going to try doing it by grouping, although we might be able to. A quick check would be negative 45. We're looking two numbers that give us negative. Oh, I'm going to do it because it looks pretty easy. So I want them to multiply to negative 45 and add to negative 4. Signs are different. Larger number is negative, negative 9 and positive 5. So we have 15u squared minus, plus 5u minus 9u minus 3 equal to 0. So 5u times u plus 1 minus 3 times u plus 1 equal to 0. So 5u minus 3 times u plus 1 equal to 0. So 5u minus 3 equal to 0. And u plus 1 equal to 0. 5u equal to 3. So u is equal to 3/5. And then u equal to negative 1. And then, oh yeah, we've got to pull this back in here. So u is equal to x to the negative 1. So x to the negative 1 is equal to 3/5. And x to the negative 1 is equal to negative 1. Now remember, x to the negative 1 just means take the reciprocal of it. So x is equal to 5/3, and the reciprocal of negative 1 is negative 1, okay? And x is equal to negative 1. So we've got those, and then it's a matter of plugging it back in and verifying that they both work. And again, I will leave that to you to verify those. Yes. Just checking because on my paper I have something written a little differently. I just want to make sure I didn't make a mistake when I did this. Actually, 1 over u is 5/3. And I had -3, whereas I came out with -1. I just want to make sure I didn't do something foolish here. I did do something foolish here. I pulled out that 3. Well, you should have caught me on that one, but this interactive video thing, you didn't catch me on that. I'm flying through that. I pulled out my 5, but that should have left me with 3u plus 1. 3u plus 1. 3u plus 1. 3u plus 1. Which makes u equal to -1/3. So -1/3, -3. There we go. So it's always good to check your work. Make sure you didn't do something, just simple mistakes. I'm going through quickly and I missed that. But that's okay, because I got to the end and it didn't quite look right. Something was wrong, so I went back and I checked and I thought, oh, oops, I left that out. So don't be afraid to make mistakes. It happens at times. That's why we go back and check. And when you plugged -1 back in, you would have found out that didn't work. So at minimum, you would have said, no, -1's no good. Whether it would have keyed you off that you made a mistake earlier on, well, look through your work again just to make sure you didn't do something that you know you shouldn't. So that finishes up other types of equations and applications. You wanted it to be done, it's done.